Test is on Monday next week, and downstairs, set up downstairs. Right, down one, just come to my office and you go one room or the other. So, chapter 3, bring your,
Are we gonna do the rest of 36, or we're gonna leave that behind?
I think we'll leave the rest go. 38, page 171, 38. Now, density, notice it's mass over volume, and the density is always going to be in grams per centimeter cube. And this kind of, dimensional analysis stuff. So it says copper has a density of 8.94 grams per centimeter cubed. And it wants it in kilograms per decameters. So what we kind of have to know is there's 1,000 grams per kilogram, right? And then there's 100 centimeters in a meter, and then 10 meters in a decameter. And make sure for the test that on those sheets of paper you know where to get those dimensions. If you don't, then
Add them?
yeah,
Okay.
because generally it's going to be the inside of the book there on the. It's not the back cover. It's the next page over. There's unit measures in U.S. Customs System. There's that. And that's going to be kind of the standard that we use. So we're trying to go for let's see, what is it? Trying to do it kilograms per decameter. So I'm going to first go grams, do it to kilograms. So there's 1,000 grams, 1 kilogram. So I'll have it in kilograms there. Now I got to go the centimeters to decameters. So I got to go 100 cubed centimeters cubed 1 meter cubed times, and there's 110 cubed meters cubed, and then it's 1 decameter cubed. So that would be, we'll have the unit cancellation. We've got it. So then we have 100 cubed times 10 cubed over 1,000. And then we'll have it in kilograms per decameter cubed. Oh man. 1.94 100 cubed should give me 800, 8,940,000. That seems wrong. We got grams. I want kilograms. The way the unit cancellation is set up, it should be right. Meter cube. That's the right way to set it up and think about it, isn't it? We got centimeters cubed, we have to do 100 centimeters in a meter, so it'd be 100 cubed centimeters cubed is 1 meter cubed. And there's 10 of those meters. I guess. So what did I have? 8,940,000. Seems like it should be less, don't it? I think the number's right.
Do we have to cube the 1,000 grams below? It does seem like an awful large number.
Yeah. Have I got this one backwards? Centimeters is 1/100th. So there'd be 100 centimeters in a meter. And it says a decameter is 10 times as big. So that should be 10 meters in a decameter, isn't it? I don't know. Just what?
I don't think the 10 would be cubed, right? If it's just 10 times.
Well, you got to get decameters cubed because it's got, it's got to be in that. Because it says they want it in kilograms per decameter.
Isn't that the teacher's edition? Did they not give you the answer?
No. I mean, I thought the answer was 8.94. I had this thing the other way around. 10 decameters cubed in 1 meter, but that don't sound right. Well, okay. We'll go B. The chunk of oak firewood has a mass of about 2.85 kilograms and has a volume of 41,000 centimeter cubed. Determine the density of the oak in grams per centimeter rounding to the nearest 1,000. Okay. So the dense, what they got is 2.85 kilograms. centimeters cubed. And we want grams. It's grams per centimeter cubed, right? And we said that there's 1,000 grams per kilogram. So to get the grams, we'd have to get 1,000 grams, 1 kilogram. And then it wanted it in that centimeters, right? Cubic centimeters. And that's already there. So it's 2.85 times 1,000 divided by, and that's 4,100, right? So it's 0.695. So this is,
See, Professor, we're doing something wrong, because if it's 2.85 kilograms, it should be more grams, not less. Something's not right.
grams per centimeters cubed. Yeah, we did 1,000. See, because we're multiplying this by 1,000, but we're dividing by 4,100, and so that 41. See, this is actually 2.85 over 41. 2.85 divided by 41. See, it's 6.95.
Okay.
Okay, it's 6.95 kilograms per centimeter cubed. That's not even right. What in the heck is going on there? That can't be in there. Oh, that's e to the -4. So that's 4 over. So that actually this is 0.12365 grams per centimeter cubed. Then you multiply that by 1,000 grams, and that moves that decimal place over 3 places to this. Kilograms. This is kilograms per centimeter cubed. Then it'd be, you multiply that by 1,000, and that gives you 0.695 grams per centimeters. So that's logical. So C says a piece of iron weighs 45 ounces and has a volume of 10 inches cubed. 45 ounces and has 10 inches cubed. Determine the density, now grams per centimeter cubed. So if you look back, we got ounces, which has got to go to grams. And the only thing that we got in that conversion is 1 kilogram is 2.2 pounds. So we got we got this conversion, 1 kilogram equals 2.2 pounds. So we gotta get the ounces to pounds, and so we have 16 ounces in 1 pound. Then we gotta go to inches to centimeters, and the conversion that we have is 1 inch is 2.54 centimeters. So if we want to get our numerator fixed to grams, and to get to this kilograms, let's see, we're gonna go ounces to pounds, pounds to kilograms, and then kilograms to grams. So there's 1,000 grams per kilogram. So let's work on that numerator. So it's going to be 16 ounces, 1 pound. And then we got to do the pounds. So it's 1 kilogram, 2.2 pounds. Now we got it to kilograms, so then we got to go to grams, so we got 1,000 grams, 1 kilogram. So now the numerator's in grams. And then we got to get the denominator into centimeters, and we got the inch conversion. So that's going to be 1 inch cubed is 2.54 cubed centimeters cubed. So if we do that, we should get it. Numerator would be 45 times 1,000. Denominator is going to be 16 times 2.21 times 2.25 cubed. So it's 45 times 1,000. And then we can just divide over and over again. And then I forgot what the first division was. It's going to be 6. Was this 10? This is 10. So we got to divide by 10, 16, and 2.21, and 2.54 cubed. 10 divided by, that was 2.2 next, wasn't it? Divided by, what was next?
2.54 cubed.
Did I divide it by 16 yet? Didn't divide it by 16 yet. And then divide it by 2.54 raised to the third. Let me see. So I divided by 10, 16, 2.2, 2.54 cubed, multiplied by 1,000. Okay, make sure you got this all right. 45 and 1,000, 10, 2.26. I think it's really good. 7.8. And I'm just going to make sure that I got just to cancel my units, make sure it's right. There's ounces, pounds, kilograms. So I have,
Just centimeter cubed left.
and I got grams left, inches, and centimeter cubed. Okay. So I got grams per centimeter cubed. 40. Okay, so while rummaging in his great aunt's attic, Bernard found a small figurine that he believed to be made out of silver. To test his guess, he looked up the density of silver in his chemistry book and found that it was 10.5 grams per centimeter cubed. So silver density. Left the name out. Is 10.5 grams per centimeter cubed. Found that the figure had a mass of 149 grams. To determine the volume, dropped it in a cylindrical glass of water. If the diameter of the glass is 6 centimeters, the figurine was pure silver. How much did the water level in the glass rise? Well, if we take the mass of the silver and divide it by the density, we should end up with the centimeters cubed, right? So if the mass that you have, grams, and you divide it by the 10.5 grams per centimeter cubed, you invert everything, so then what you would have is you get 149 over 10.5, and this is grams, and then this is grams, but in the numerator you have centimeters cubed, right? So that would give us how many cubic centimeters. The silver should displace, the object should displace if it is pure silver, right? And then it says, if he dropped it into a cylindrical glass of water, the diameter of the glass is 6 centimeters, and the figurine was pure silver, how much did the water level in the glass rise? Well, you know, the glass is going to have that looks like a cone, not a glass. Then it's asking how much did that height raise if it truly is pure silver. Well, it should raise so the volume that's displaced is this much, right? And if this diameter, they said the diameter of that glass was
6 centimeters.
6. So this is 6. So that means the radius is 3. So what this should do is the area of the base times the height, so it's pi r squared times h would have to be the amount of this volume would have to equal that amount, right? So that's 149 over 10.5 centimeters cubed pi times 3 squared. H we wouldn't know. That would be the height that it would raise in that glass. Right? So H, if it's pure silver, and we divide both sides by pi and 3 squared. It's 149 over 10.5 times pi times, if I put 9, it confuses me. I'm dividing both sides by pi 3 squared to get h. And this would be the height in centimeters. Okay, that should be it, right?
Professor, isn't density mass over volume?
Yeah, see the density is 10.5 grams per centimeter cubed. So I'm dividing by that density. Here's the density. But I'm dividing this density into the grams that it weighs. And what that comes out with is that the grams will cancel and you get a volume of centimeter cubed.
To get volume alone though, wouldn't you have to multiply both sides?
So if I take this thing right up here, so I'm dividing by the density into the weight of the object. And if
Okay.
it's silver,
Okay.
see it's 149 grams is what it weighs. So I invert and multiply. So I got centimeters cubed over 10.5 grams. And the grams drop out. And that tells me how many this 149 over 10.5 tells me the volume that should be displaced if it's pure silver. Then I'm putting that volume right there, equal to pi times r squared, and h I don't know, and that'll be the height that the glass rises. That makes sense?
Mm-hmm.
So now, if I do 149 over 10.5 times pi, divide by pi and divide by 9. Okay. 149 divided by 10.5 and divided by pi, right? And then the last one was divided by, what was it? 9. So if the water in the glass rose 0.5 centimeters, then we can conclude it's silver, right? If the object is silver. Is that right? Does that make sense? I mean the units come out, right? So, okay, I'm going to assume we're okay. 42. It says the standard tennis ball can is a cylinder that holds 3 tennis balls. Which is greater, the circumference of the can or its height? Okay. Well, A. the height is it's three balls, right? 3 times the diameter, and its circumference is pi times the diameter. So which is bigger? See, the circumference is pi times the diameter. But the diameters are equal, so which is bigger?
I
3 or
figure the
9?
three.
So the circumference is bigger than the height. Circumference is larger than height. If the radius of the tennis ball is 3.5 centimeters, what percentage of the can is occupied by air? Okay. I'm just going to draw this thing. So I can make something that's. I should have drawn the top. I'm going to undo that. Top first. The radius of the tennis ball is 3.5. So what we're going to make a judgment here is we're going to basically say that this diameter is 2 times 3.5 equals 7. Diameter is this. The radius is 3.5 of that can. Okay. Then we have those 3 balls that are in it. And then, they occupy clear out to the edge of the. So that if we take the volume of the can and the volume of the sphere, 3 times the volume of the sphere, subtract the 2, the volume of the can, and subtract 3 times the volume of the spheres, it should be the volume of air, right? And then to get the percentage of the can, we would take the volume of the air divided by the volume of the can, and that would give you a decimal which you convert into percentage. So that's what we're going to do here. So the volume of the can is the area of the base times the height. So it's area of the base times the height, and the volume of the sphere is 4/3, and it's 3 times, 4/3 pi r cubed, isn't it? That's the formula, isn't it? 4/3 pi r cubed, I'm pretty sure. This is going to equal volume of air. So the area of the base is pi times 3 squared. The height is actually, this height right here is actually 4 times, let's see, 4 times the diameter, 7, isn't it? No, yeah. Each ball's diameter is 7. So radius is 3.5. No, it's 3. What am I? I'm putting 3 balls in there. It's 3 times the diameter of the balls. So that'd be the height. Correct?
Mm-hmm.
3 times 7. No. This is 3 times 4 thirds pi and
Professor, the first part, pi r squared, you got 3, should it be 3.5?
just wait. Let me finish this and then I'll go back. This is 3.5 cubed air pi. Now, okay, this is wrong right here because the radius. That's what you're saying.
Mm-hmm.
Pi. The radius is 3.5 squared. Then the height is 3 times 7. And I got 3.5 over here. So it's going to, this is going to cancel. So I'll get it kind of down to numbers. 3.5 squared. This will be 21, right?
Mm-hmm.
Minus 4 pi 3.5 cubed. Okay. So it's pi times 3.5 squared, and the height was 21. So that's the area of the can minus the area of the balls. And there's, let's see, I did some canceling, so I canceled that 3. So it's 4 pi 3.5 cubed. 4 times pi times to the third. No. So that's going to give me the volume of the air. Sure looks like a lot of volume of air. What is that? Is that inch? Do we get all of our things in the same units? Yeah, we did. Because it's inches, isn't it? Centimeters. Okay, centimeters. Okay, that might be okay. And then we're going to divide it by this number here, right? Volume. The percentage air has got to be the volume of the air divided by the volume of the can times 100. So that number that we calculated, volume of air, we'll divide that by pi times 3.5 squared times 21. Okay. So I can just go divide, right? And that'll pick up that answer. Second pi. And then divided 3.5 squared, and then divide again. What was 21? That was that last number, wasn't it? And then times 100. 33.3%. And 1/3, right? Percent here. A few of these would take making Howard examine it.
That's what I mean.
It's good for thought. Okay, which one do you want to work on? 44 says the cylindrical steel pipe has inside diameter and outside. The next one down, 46, is the swimming pool. How much stuff does it take to tile it? How much does it take to fill it? Or 48, water treatment plant with a cylinder digester 25 by 20 feet and puts this material in a 60 by 20 by 15 inch high. Which one sounds most interesting? Which one might be practical for you? I was intrigued by that water treatment one.
Let's try it.
Does that intrigue anybody, or which one of those intrigues you most? Or do you have any?
I'm not even gonna
Any-
answer.
Any one of those three kind of give
Anyone that we can do in
tickles
the
your
next 2
fancy?
minutes, because I'm already in the car driving. I'm already on my way, Professor, I'm sorry.
But I guess I'm gonna do the one I thought was, when I read it, I thought, that's kind of an intriguing problem. Water treatment plant has a cylindrical digester 25 feet in diameter, 20 feet deep. So you got this. This digester. I don't know, I just thought, that's kind of a practical, I guess all of them are pretty practical problem. Okay, the thing that's important is what diameter is 25 foot, right? Technically, this distance here,
It's your height.
yeah, it's not gonna be so important to the problem. You're assuming that the thing is full, but the only thing is if it dumps it into rectangular drying beds, and the beds are 60 by 20, so you have,
This is kind of like the cake pan problem.
yeah. But I thought, you know, that's, maybe that, I just think the Chadwick States got its little drying pads out there, out of town. Yeah, there's a couple of these. They're not Chadwick State, the town of Chadwick. Usually they're both supposed to be the same size. So, and these things are 60 by 20, so I'll just say 60, and make this 20, and then this distance here is 15 inches.
Might as well just convert that to 1.25 feet.
Yeah, that's a,
Save yourself
So-
some grief.
divided by 12, right? That'll be feet. This is foot. And then it says, if the pads fill to the depth of 25 or 15 inches. Now, the pads apparently are got capacity more, but you fill them to 15 inches. How many inches will the level of the digester be lower? So
Two
with
pans,
the two volume of the two pans,
deduct it from the volume of the cylinder.
and then what you do is you take the formula for the cylinder, which is radius, the area of the base, pi r squared h equals 2 times 60 times 20 times 15 over 12. And then you know this R is 12 and a half, so 12.5. And you solve for H, right?
Mm-hmm. And we have 8. Oh, I see.
No, you can't use, that 20 is a,
Understood.
is a, is, oh, it's, yeah. That's it. Then you just multiply, you solve for H.
See the remainder left in this one.
Yeah,
Professor, I'll see you on Monday. Enjoy
it's
the meeting.
interesting.